Okay, let's try this again. Now recording to a location that actually has disk space. Encoding the previous video, I hope it doesn't mess things up. But you don't want to watch me spend the 10 minutes fixing type errors anyway, so I've got it to the state where it actually compiles and doesn't draw right. You can see we're flying around an invisible spaceship while the visible one sits there in the middle. That is probably because I have not made the draw player function actually draw the player correctly, at a guess. So we can take a look at the old draw player function, except I deleted it at some point, and figure out what we're going to do now. The drawing we're using, by the way, is all OpenGL with a vaguely convenient set of wrapper functions around it. Okay, well, first it's not drawing in the right orientation or in the right place, so we're going to need add a translation and rotation to that. Okay, so the drawing rock function works, so we'll just grab half the code from that for the moment. So we have a list of vertices we want to draw that will someday get loaded from a file or something. So we run the actual game at a fixed rate of 20 frames per second, but we can run the graphics at whatever rate we want, in this case 250 frames a second, and just interpolate between where the player or whatever object actually is and where it will be soon. And this means that actually, so on the draw function, you actually see, you get the object you want to draw, you get the last position it was in, and you get the dt, which is the number of milliseconds it has been since the last frame. So this is a good example. So you actually draw a frame behind of where the game state actually is, but it's a 20th of a second, nobody's going to notice. The latency on human nerves is something like a 1/10 of a second, so you figure out, you interpolate the location between the old and the current objects, and then you translate color, scale, and draw it. So I'll probably get more into the drawing stuff later, but at the moment it's really not that interesting. So we just replace the scale down and draw a circle with okay, let's try that. Hey, it's actually compiling. That's hopeful. I might actually remember what my drawing functions do. It's been a while. So let's see if it works. Oops, didn't do the rotation. And didn't do the coloring. But, hey, it's a good start. Rotation is easy. Translated. Want to... yeah. This does not look like most OpenGL code you have seen, but facing, not rot. I don't really want to get into the details of how it works. Basically, instead of listing functions one after another, you compose functions in with each other. And hey, there we go. Looks pretty good. Fix the color to make it a bit more stylish, at least. And how are we doing for time? We're doing okay. There. Buck Rogers red. That's what I want to see. We don't have anti-aliasing, but that's something that will get done to the whole screen later in the processing pipeline. So right now we're really working on structure and game logic. Okay, so success. What do we want to do now? Now, let's take a look. We could do collision detection, or we could do adding shots to, making shots happen and adding them to the list of game objects, but those are both kind of big projects, so we're gonna just do something small and cosmetic. So we've added a facing option to the rocks, and here we go, draw rock. We'll add a rotation.